Open the Projects tab, right click, New Project, not New Folder, name of the project, right click, New Schematic, that's what we're starting off with. Schematic is the blueprint. Open up our window here, and that's basically where we would start from. It's a clean canvas. Okay, let's go over the Eagle GUI. Left hand side, icons, you all know what they are. Down to the bottom left, tells you what they are. Just go over them individually on your own, see what they are. On the right hand side, obviously this is default layout. Text labels, smaller subset of what's available on the left, but the basic parts, basic shortcuts that you're going to use. You can use either or, it doesn't matter, they're exactly the same. You can also use the text interface, type stuff in up here, type stuff that makes sense though. I prefer the console myself, it gives me a little bit more working space and I'm just used to it. Obviously on the top, just the regular menu where they are repeated again and shortcut keys. So that is the basic GUI. Okay, let's look at some basic Eagle stuff. One of the most important things about Eagle, and it tends to catch people at things, is the grid. So let's take a look at the grid. Either click up here in the top left, default, type grid, or G-I-R-I, and what we see here is basically the default Eagle grids. Just to make sure. So it's in inches. It's typically best to stick to inches, even though most of the country uses metric. But board houses tend to use inches, and if you use millimeters, you'll get giant boards back or really tiny ones, and everybody gets really confused, so we all tend to stick to inches. This is fine for the schematic, we'll leave it here. We'll look more closely at the grid a bit later when we get to the board, where it's much more important. Display, turns it on, turns it off, very simple. Okay, so that's the grid. The next thing we want to do is actually start drawing with primitives. So let's look at the wire command. The wire command is used either to draw symbolic wires or actual wires. So we could get over here or over here. As you can see, left click to start wire. This is the PC version. We want to use 91, which is the netless layer. I'll go into that later again in a bit more advanced class. Don't worry about it right now. And these are the types of wires we're drawing. Eagle will automatically try to route the wire as best it can. Mitre basically makes them circular at the edges. Width is the width of wire in inches. Continuous, long, short dash, that's for symbolic stuff, so if you want to draw dotted lines and so on. So basically pick where you want the wire to go through, left click, down, draw it, that's the wire. It will keep doing that until you cancel it. If I hit the escape button, that does it. So same thing again, left click, and if we move around you can see the way that the wire type is going with the highlighted one at the top right here. So that's how that one's highlighted, so it's kind of drawing that shape. If you click the right mouse button, it will move to different types. This is the freeform one. Here we go, another type, another type, another type, and so on and so forth. I tend to stick to this one, but we do change it. So there we go, a wire. Press escape to cancel drawing. Okay, so let's start creating the schematic. Over here are the sheets. We're only going to use one sheet on this particular circuit because it's very simple, but you can add new ones, and basically it's 2 blank pieces of paper. Let's remove them for the time being. Go over here. So the first thing we want to do is use the NSL library that I've pre-created for this class. So we go to library, to use, select the library, browse to it, open it. And now Eagle now knows about the components that are inside that library. So then when we click add, it will bring up the list of all the libraries that Eagle knows about. Some of these come with Eagle, some of them have been created, downloaded from the internet. So a note about libraries downloaded from the internet. A lot of people create parts, they just kind of have fun doing it and upload, but they never actually verify them. The SparkFun library that tends to be out there, people use that one a lot. That has a lot of verified parts, but it also has a lot of unverified parts, and some of the parts are just plain wrong. But they do warn you about this, but regardless, people make them anyway. So that's why I like to either create my own parts or verify them before sending them off. So let's scroll down, let's click type N, and there is the NSL library. I want to open it up. These are the parts that we will be using for this particular schematic. We're going to start with the AT Tiny. There's the symbol for it. And we want the MLF20 version of it. So this is the small micro lead frame, or QFP package. And we're going to use it. So basically click on it here, it'll be here, and then click OK, and here it is. So pick a place where you want to drop it down to, click, and there it is. That's as simple as it is. This works the same way for every thing we add in Eagle. So the next step is to basically use the rest of the schematic. So let's have a quick peek at it again. It's a very similar part. This has a slightly different layout, so we have to watch for that when we reverse the schematic. And we look at the wires and the different parts. So where they go, back to Eagle. Alright, so let's look at the schematic we're going to make. And if you're living on a tree, it's this guy, which is this. Evil Mad Science, Doctor Who, it goes back and forth, Cylon, we all know what it is. If you don't, get out. And what we're going to take is make this and make it smaller. So here's the schematic for it. We're going to make our own. It uses the ATtiny 2313 Atmel chip, which is very, very small for the version we're using. They use the DitPick package, which has the pins that you're probably used to seeing. A couple of resistors, a few LEDs, decoupling cap, switch, and a program header, and then the USB port. Probably going to only put some of these on because you don't really need the TX RX lines, and we need the optional to be able to chain them together. So the first thing we have to do is convert this into Eagle. Okay, so we've added the AVR. Let's add some more parts. Click add. Okay, we don't need the processor anymore because that's already there. This is the pin header for the JTAG. It's actually the in-circuit programmer. So let's throw that down there. We're just going to throw the components on here one at a time as we need them. The switch. That, and pop it down. Now you can zoom in and zoom out with the wheel mouse if you have one. If you can't, you can't. So, okay, let's add some more parts. We need the battery. We're going to use the 20mm PTH. So that's the one that we have for the thing. Drop that down. We're just kind of randomly placing the parts around at the moment, no particular order. Capacitor. Obviously, I'm doing this all from memory. So obviously, these different size of capacitors: 402, 603, 805s. 402s are very small, 603s are pretty small. So let's go with pretty small. Click OK, and we're going to drop that one down. That one's C1. Okay, and again add. And let's add the jumpers. So at the edge of the board, there's going to be two jumpers, an input and an output. So let's take those. We will take these two here. So these are through the whole components. Now, one thing Sparkfun does is kind of interesting. They have the lock. So this would be the normal one with correct spin spacing. What they do is you can look at the top here, they'll change. And you basically just move it out ever so slightly, and that helps them when they're creating their products by hand. So it offsets the spacing a little bit, and so when you put the through the whole component in there, it'll stay in there because it's being held, in the holes, whereas this one normally wouldn't, and it'd fall out. So they use that as part of their manufacturing process. It's kind of neat, but it also means that you can't do spacing the same, and I use the middle of these components to run wires through sometimes, so I'm going to stick with the regular one I have. And let's drop those down. So we have two of those, one for each side. Okay, let's next add some resistors. So they're going to be a resistor for each of the LEDs. Again, these are the sizes. We're going to go with the 603s. Again, you can change these later, so it doesn't really matter. Let's pop them down now. What I did here is I'm pressing the right mouse button, and that's allowing me to rotate the part. So let's start by dropping this down again. Picking a random kind of location at the moment. I'll show you how to move things around. And drop them down like this. And we're going keep things in kind of the order that the original schematic was. Eagle numbers from 0, but they are actually numbered from 0 through 8 in the original schematic, so we'll keep that. And I'll come back later and name R9 to R0. Okay, next is the actual LEDs themselves. We're going to go with the bigger ones that we can get, which are the 1206s, and drop them down. Obviously, again, look at the schematic. We're going to line these up. Oops, didn't need to do that. Control Z gets rid of it. Could have moved it, but I didn't. Again, line up, pop it down. And again, keep doing that until add it back over here. Add number 9, which again is going to become 0. We're going to rename them anyway. Okay, so we've added, I'm going to hit Alt F2 here on the PC. That's going to do a zoom to fit all of the parts that are currently on layout. So are almost there, including. So let's use another one of the commands called move, which basically allows us to pick up parts and can move them around a little bit, make things a little bit neater. I usually like to add most of the components first before adding any of the wires. So the next thing we're going to have to add is power and ground. So let's look for that. I'm going to use the VCC supply symbol, which is basically just a schematic. I'm going to add the battery side, one for the decomposing capacitor, and then that's it for the VCCs. Okay, next we're going to add some grounds, and these basically just tell Eagle what we're connecting to the ground, and later on to actually draw onto the board. We have a few different grounds here. Pop them here, and another battery, one coupling capacitor, and one each for the 2 jumpers. And that is it at the moment. Okay, so one of the things you'll notice here is that the grounds have very long names, pretty ugly looking. So the other thing you can do, instead of actually individually adding them, which is like this, it's like ground, click OK, left mouse button in place, left mouse button in place, left mouse button in place, and go on. What we can do, remove those with Control Z, is basically go here, and some parts, depending on who created them, either use the, let's move that into view first. Okay, there we go. So you either use the value or the name. This particular part, I believe, uses the value. So there we go. And what we want to do is change that just to ground like that. So it's now called ground. Now the next thing we do, right click, copy, pop it down, and copy, click, 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 left mouse, copy. And that way it's a lot neater. So let me Control Z those away so that we don't get mixed up. And then later on, instead of doing that, we can use the value command with clicking on it. And as you can see, it's really, really annoying because it keeps doing that. Yes, we really do want to change them. And that's because this part was built, I would say, somewhat incorrectly. Same thing for VCC. Because VCC is going to be there. Oops. Typo. Okay, so now we're all called ground, which is a lot better. But so we say we're going to rename this resistor because it wants to be R0, so we're actually going to use the name, which is the correct thing to do, so R0. Same for the LED. This one's actually D0, D1, and I'm just using the name command here, which equal stays in the last command you selected typically, and it will be highlighted. So let's see, where do we get to? 86, which seems odd, like I just missed one. 0, 1, 2, 3, 4, 5, 6, 7, alright, and 8. There we go. So that will keep those in line. And now they've matched the original schematics. I believe that is all of them we want want to change the name, we've got the jumpers, we've got C1 here. Now the other thing we can do is come in here and click the value, and the value is basically the value of the component. In this case it's a 0.1 microfarad, and there we go. What else do we have to do? Let's just call this guy, he's going to be JP1, and we'll see here probably the difference between value and name. It's added it to the lower end. The value was here, this is the one we want to change. And then for the switch, S1, which is going to add one, but let's use name, is S1, and then name for here is going to be JP1. So, oops, we already gave it the name. Oh, right, because these guys are already called automatically by Eagle. So let's just rename those so it's a collision, and this time it'll be fine. Okay, so that's laid out the basic components. The next part would just be kind of arrange them into a neat order and start drawing the wires between them. Okay, so one of the other things we can do with Eagle is add attributes, and attributes are basically user-defined values that we can add to parts for our own use or for script use. And in this case what we're going to do is we're going to actually add the part number that we want to use to order from my DigiKey of the parts, and this can be used later to build the BOM, which is the bill of materials, in other words the order. So load up the attribute, right click attribute on the part you want to add to, click new, and then click value. And then I like to put in just simply DigiKey and value. Now off we go here, and DigiKey, and here's the part. So DigiKey part number, copy it off, over here, paste it in. Okay, so now it has the actual part number. But with Maser, alternate part numbers, or the OEM original part number for when using fine chips or something, you want to keep display off because otherwise the schematic will get really cluttered up. And then later on we can actually write a script that would export all of these out into a nice way for us to create a bot to show them. And that's how attributes work. Okay, so let's go over what we've done already. We've added each of the components with the add command. So again, add, pick the component you want to use, and click OK. And that will get you the components to the board. We've used the move command to move things around. The name command, which allows us to set the name of the package, the value, which there is no value on a CPU, so let's use something that makes sense. So capacitor, 0.1 microfarads, and then there's smash. So we haven't looked at smash yet, so let's do it while we're in here. Smash basically allows us to move the labels. We'll select move now, and you'll see the crosshairs have appeared here on the two names. Now I can move and rotate those around and make them look all artistic and stuff, and that's what smash does. Move those around. Let's bring that back in. Change the name. Make something normal. We can use the group command. Now the group command is kind of interesting. Typically what I do is I set the command I want to use after the group. So I'm going to select move, and I am going to group these together. Let's group this guy here. Right click and move group, and now we can move them around. Simple as that. Put them down again. Move group. Blah, blah, blah. And so, okay, let's wire up the board. So, select the wire command, and we'll go through each one of them. So start over here on the left, and to connect up battery. I'm using the right click here. Escape. Turn to the ground, right click again, and escape. Same for the decoupling capacitor. Making sure that we touch end to end. So zoom in here. Oops. Okay. Let's drop these guys in. the other thing you can do is actually you can copy these as well, but which for in a minute we'll realize why it's a good idea. So okay, so I'm actually re-recording this one part because it didn't save. So I'm just going to go over the class again. So the classes, we already pre-filled these in. The name of the class, the index number of the class, and then what that class does. So we can assign these to different wires, 12 mil, 20 mil, and 10 mil. And that is going to be the default width of the trace. 0 means it's no width at all, and just use the default setting. And now we're going to use these to actually change the LEDs going between the resistors and the diodes to 20. So there's a couple of ways of doing this. The first one is just simply to right click on it, select properties, and make a class. So there's a LED, and that will change that wire now to 20 mil. The other way to do it is just simply to do change class and then the class index, which is, as we can see, wrong one. So that's number 2 we want to change it to. Change class 2. 2, and the green light flickers. 2, 2, 2, and this is just clicking on them, they're all changing. So those ones are on 20 mil, and that will come on later when we're actually routing out the board. You can also set the class to which one you want it to be as you're adding the wires. So we'll put it back to the default at the moment and fill in adding some more wires. So let's drop in these guys, which are the resistors to CPU. Let's just click escape, click escape, click escape, click escape, click escape. There we go. And then next would be the ground, and what I'm going to do is bring this one down here. See if I can find a neat one. No, we're not. So bring it up to there and there. Okay, so that's going to make that automatically change to a ground. He says hopefully. Yep, there it goes. So I filled in that name, and it's a power class. So that should change all the other ones, and that will give us our default wire size for the ground. And now we will fill in the rest of these, and these ones will automatically be turned into ground and have their width changed. Okay, and now that we're going to do this, we're going to explore another part of Eagle, which is making junctions when there is more than one connection going to a wire. So we're going to use the junction command, and basically all it does is that little drop, just to let us know we do mean those wires to actually join together and they're not just crossing. So we'll do that, and we'll explore that one a bit later. Let's see, what should we have next? The ICSP in Circuit Systems Programmer. And then the switch, let's move this ground symbol around a little bit. Bring it over there. Bring another wire in, and we're going to do this and that, and over here, and over here, and we're going to add a junction on this guy just because there's 2 wires there. Okay, now let's figure out the CPU. Let's move this out of the way from before, and the wires. I'm just going to go through it just to speed it up by adding all the wires first, and then we'll go through and we'll name them. And that's basically, naming them is what will actually join everything together. Also, Doc Who is completely wrong about the resolution of the projector, which is great. Thank you, Doc. Okay, so I think that should be all the wires we're going to add for right now. Let's just go through and check a few things. The power class is okay for that one. This one probably doesn't have one yet because we haven't named it. This one will have one because we have. So let's see, wires here, wires there, all those wires again. Okay, so now what we're going to do is join things together. Obviously over here it doesn't go anywhere, we do want it to go to the chip, but instead of drawing a wire like on the other schematic, I'm simply going to name these nets together, the nets being the wires, and they will automatically join together once we have two or more of the same name. So let's pick up with the, let's take the LEDs first. So let's put the name command in, and we're going to name this wire, and it's B2. Someone's MMCA is asking me if a 1210 LED will fit without altering the board. It will, because I redid the pad from the SparkPun library and made it a bit bigger, just so that we could do stuff like that. So the answer is yes. However, you won't want to find out until tomorrow, because this is a recorded video. So, okay, we're going to go through these and label each of them individually. And one of the interesting things is that it's kind of hard sometimes when you do a big one to realize which ones you've done, especially when people are talking to you on IRC. So a good way to kind of do that is use the label command, and the label command just basically do this. And that way it's really easy to tell which ones you haven't done yet. Those have to change to N pound or N dollar, whatever you want to call it. So let's do that on all of these. Rotated. Clicking through these here, and this will help us, or at least it'll help me remember, because there's like 300 million things going on. That's not an exaggeration. Okay, well, maybe a little bit. Click faster, damn you. You can actually add multiple labels, which just happened there, for some strange reason. If you want to add the label twice, someone's texting me. What we're going to do is pick this guy here and just rotate him around. There we go. Okay, so that's all the ones I'm going to name for right now. Move that one over to add not the wire. Use the right mouse button to move it. Okay, good. Now we'll go back to where it was before. To label, the name command, and we're going to start back off where I left off before, which should be PB1, PB2, and finally PB3. You'll see the names are changing through the label command, which this one is PB4, and then the circuit, which is not a non-standard layout. If you can route it on a single-sided board with a standard layout, be my guest. So now it's asking me if I want to join them together, because there's already an existing name of VCC, so this will actually physically join those two together. So VCC will now run to there. This one's the reset line. Use pilot NSL programmer, and now we're going to ground. I'm just going to ask the same thing again. I turned off that stupid beep in the user interface. Now in the sign. Okay, well, those three choices. There it is. Beep is turned off. Look at that. No beep. Why is it beeping? Anyway, let's continue onwards, naming these. This wire is not actually used in our circuit. It's RxD, used for a serial programmer. This one is PD2, and now it's going to ask us, and very annoyingly, beep every stupid time. Yes. PD4, I think. PD4. Look at that. That's going to PD5. Yes. PD6. PD0. And the other thing you can do is actually type in the actual name there, and then name that like that. So it's just going to slightly shortcut. So PB3, Christians. Yes, I do have red LEDs available. connect those together. That one is MISO, the SPI, and this one's the clock. So there we go. Over here, this should be reset. Yep. This one's going to be the crystal, which is also a multi-purpose. So that's PK0. That's the input and the output we use for chaining the boards together. VCC, join them together, and ground. So there we go. So we should have it all wired up now. Let's have a little quick go over it. I think we're back to where we were. Yep. Let's check the classes, make sure they were default. They are. Make sure the ground is ground. Power is power. Indeed it isn't. So there we go. Change VCC to power. And that should be that. Okay, so let's check all these out. Ground reset VCC, S-Clock, MISO, OC. They'll line up. Quick sanity check. Okay, we're going to change these two here to TXD and RXD, just for completeness. VCC ground. Okay, now we just have to add wires to the options, or rather, sorry, just name them. This guy is PA0. This PA1. There we go. Got the whole circuit again. Now, obviously, since we're not doing an electronics class here, it could be difficult for some people to follow, but basically all we've done is connect from ground through the LED through a resistor to PD2 on the CPU to over here, and then these are basically jumpers, just like the normal type you're probably used to seeing. It's basically just going to be two holes on the PCB connected to ground, which then is going to run from here all the way over to PA0 and PA1, which are these two here. So the wire effectively goes from here to here. Let's label those so that we can know that we've done them. Let's rotate it too. So that's good. And let's take a quick overview of what we've done. So we have VCC and battery. One of the really easy mistakes to make when you're designing a circuit board is to forget to add power. We forgot to do it on the NSL alcohol BAC board on the first couple of revisions. I did it actually on the first revision of this one. I forgot to put the VCC onto the jumper, and although it was here and there and it was before the battery was added, it meant I had to add a little wire to it, and I'll actually show you that to you in a little while. So yeah, power is a really important thing to check, and because I designed the circuit board, or the schematic this way, where I just kind of have these little sections, you can kind of miss things. But even when you do it as the other style, which is this type, you can still miss things because, as you can see here, things are split up. So there we have it. Radically different looking, but completely the same. Now what's kind of interesting about this one is this one makes it a lot easier to lay out in the board, because this is the PCB follows schematic rule, and we'll see why in a little while. Whereas this type is basically just a collection of components broken into each of the sections. Like we have the CPU, ICSP, switch, and LEDs and diodes, just battery lumped into their own specific groups. Now I could actually split these off and put them onto their own schematics, but I don't think there's really any point on here. So at this point, we really laid out everything we can here, and now what we can do is look at what we could add. Text command is going to let us add text, obviously. You can set the ratio, which is the thickness of the letters, and then the size, which is the dimensions. And put a little thing there. So do that. A good thing to always have is the author and the date. So 10/27 is this revision, and put that there, and then later on who made it and who's to blame for when it doesn't work. So that's basically about it. We've gone through this pretty quickly. I realize there's going to be a lot of questions, so don't worry about asking them. But there's our schematic. Everything looks okay. If there's any mistakes, we'll come back and fix them later. One thing we haven't done actually, when I'm thinking about it, is assign values to the resistors. So what I'm going to do is, first of all, I'm going to type the command correctly, and those resistors are 16 ohms. So I'm going to put 16 ohm, I'm going to put 16 ohm, and I'm going to click on each of these, and you'll see the name is appearing as I click them. LEDs we don't really care about, so let's figure out just quick triple check. So switch don't have a value, JP1 does not have a value, the IC doesn't, jumpers don't, capacitor we already did, battery we could put a value on it but we're not going to, so it's just really the 16 ohms, and that's for the particular color of LED that we're using, so we're just going to go with the 16 ohm modem. Save this, save it as, and it's obviously the NSL Cylon 1 because I've already made this, so there's a Cylon existing, and that's it. And that's the first part, is making the schematic.
you